Running AI on tiny devices like this particle board here is really hard. But is it? Right, that's what we're going to check out today with Edge Impulse and Particle. My name is Olivier Bloch. I'm an IoT advisor, and I like to share content like this video here for my own experience, but also for your knowledge. So I've tried out and played around with Edge Impulse and Particle for some time now, and I want to share what I discovered. It's actually really simple to do what I'm about to do. Here I have a little accelerometer. It's connected over the SPI network bus to my Muon device here, which supports a module, which is an M-SOM module. Just for the sake of it, it's a very cool device that has a bunch of types of connectivity. So if you like multi-radio or need a multi-radio module, that particle device is great. It has Wi-Fi, it has cellular, it has GPS, and through the Muon board, it also has LoRaWAN, right? And wired network. Pretty cool, can run on battery. Here I'm connected over USB to my dev machine, and that's pretty much it. So why do I say that building AI or working on building an AI model for a microcontroller is hard? Well, there are various aspects of it that makes it hard. But here are the main ones, and we'll see how Edge Impulse and Particle are solving these problems or addressing them. First, you need to collect a huge amount of real sensor data for your models to be trained, right? That's something which the more data you have and the best the quality of the data is, the better your models will be. So you need to have quality data and you need to have a lot of it. Problem is, these devices, they don't have much memory, so they can't store data sets locally, and so you will have to have a way to export data from the sensors and then use that. So we'll see how that does. That's done with Edge Impulse and Particle here. The other one is building TinyML models, optimizing them for targets. And so this is something that implies there's various options. Once again, that implies picking the right engine, the right compilers, doing the right optimizations, the right filtering on the data for the training, and so on. So Edge Impulse does all of that for you in a tool called Edge Impulse Studio. And we'll kind of see at a high level how that looks like. But we really want to focus on the aspects that are important, which is why is it simpler or simple to do AI at the edge with Edge Impulse and Particle. The third aspect is that iteration you have to go through when you need to start testing your model. Right? You train your model, you want to test it on a real device. Well, how does that work? Well, usually you would have to export the model, integrate that into your code, compile your binary firmware, deploy the firmware, flash the device, run it, see how it goes, and then go back, right? So kind of a tedious and long cycle, and then you might iterate several times. It's kind of hard. So we'll see how you can make it happen in a way simpler way. So let's get into it. This is Edge Impulse Studio. I'm logged in. I have an account. So I want to show you real quick, how you create a new project. I'm not an AI expert. I'm not a data scientist, but still I was able to do something here. So I'm going to create a new project. I'm going to call it Test Edge Impulse, for example. And, I want to show you a few things in there. In there, you would be able to connect devices. There's a collection of devices that Edge Impulse supports by default with a pre-built binary that allows a device to directly interact with the Edge Impulse cloud. But here we're going to do a little bit different. Then you do your data acquisition from the portal. Once again, you'll see how. And then you create your model. They call that an impulse. You train it after setting up all its filterings and different analytics blocks and neural network settings. And then you export a model in a format that is the one for your target, right? That's what Edge Impulse does. It's a fantastic tool. Go play with it. So this new project here doesn't have any devices connected to it. Let's look at how we can do that. So if you hit connect a new device, you'll see some interesting options. You can scan a QR code on your phone and use your phone as the device. It has a motion sensor. In my case, this is something that's going to use motion information. You could do that, but you also have several other types of data you can send from your phone, like a picture, if you want to do Vision AI type of model, but we're not going to use that. You can connect to your computer, so use some application on your computer that will send data, or you can use this little functionality, which is connect your device or development board, right? And there's a tool called Edge Impulse Data Forwarder for that. This tool is a CLI tool. It's installed on my machine, and we'll see how to use it in a second. It will feed from the serial connection, so serial over USB in our case, and we'll get that data and send it to the Edge Impulse project. But for that, you need data coming from a device. Let's switch to Particle. So here I am in Visual Studio Code. I have installed the Particle Workbench. I have created a very simple Particle project, was like following the tutorials. It was pretty straightforward. And I did import a couple of libraries I want to show you. So the first library I've imported is the ADXL 362 DMA. That's basically the driver for the accelerometer that I'm using here. And the second one is the ADXL 345 Edge Impulse library. And this one is the one that has code that shows me how to get the data from an accelerometer and send that up to the serial connection, right? So if you look at this code in there, it's pretty straightforward. It has the option of using one or the other of these two very popular accelerometer, ADXL 345 or 362. I have the 362 in my case, so you'll see how I force it to use the right one. And then in the setup, it does a little reset of the accelerometer object. We'll read its status to make sure that it's ready to go, and then we'll set up some filters in there and then set it up to set measure mode. In the loop, every now and then, it will read X, Y, and Z value on this accelerometer, and we'll use that EI printf function, format the three values X, Y, and Z acceleration that has been converted from G's to meters per second, all the way up to the serial connection. When you look at the EI printf function, it's basically just a serial.write call on that formatted string, right? So pretty straightforward. So I did copy all of that code here and drop that into my edgeai project.cpp here, right? So in here, the only thing I did was uncomment that one line here to force the use of the right accelerometer, the 362 one. The rest, I didn't touch anything, and it should be working. So I did actually compile and flash this, and it's now running. So if I look at the serial connection here, what's going on, I can see that I have data coming in. And if I want to show you what's up with it, that's with my device. I'm able to move things around here, and you see the data is changing accordingly, according to my movements here, right? So let me close the box here. Okay, so it's working. We have data flowing over serial connection all the way up to my laptop. So, but the data is still not yet up on the Edge Impulse cloud, right? So let me go back to Edge Impulse. Remember, connect the device. Here you have this option for Edge Impulse data forwarder. So let me bring up my terminal. So here I'm going to call this tool Edge Impulse Data Forwarder. I'm going to use --clean to clean up whatever other settings I had before, right? To restart from scratch. It's asking me to log in into my Edge Impulse account, entering the email, entering the password, and then it's detecting different COM port, different serial port on my laptop. So I'm going to select the COM3. That's the one I was tracking serial connection in VS Code terminal earlier on. And now it's asking, hey, I'm connected to your Edge Impulse instance, and I have two projects. I just created that test Edge Impulse one, so I'm going to connect to this guy here. It's detecting the data coming in on that serial connection. Remember, XYZ data just flowing in. So it detected that. It says it's coming at the frequency of 10 Hertz, which is great. I love that. And it detected 3 sensors. And it's asking me, how do you want to call these values? So I'm going to say Axel X, Axel Y, Axel Z, right? This is like kind of naming them, right? And now it's asking me, hey, how do you call this device? I'm going to call it Olivier Muon. Okay, so now the Edge Impulse data forwarder grabs the data on serial connection from the real device and sends them all the way up to Edge Impulse. And in here, I can see my device now appeared, and it's part of my project. It's one of the devices. Now, if I go to data acquisition, it detects the device, and I can start collecting data with real sensors all the way up into Edge Impulse. I'll call it that. So let me do it. So here I'm going to bring up the device so you can see what's going on. So device is here. I want to do a up gesture and a down gesture. That's what I want to recognize, right? So I'm saying, hey, the default is 10 seconds of capture, great, and frequency 10 hertz. So basically that's the flow at which the data is going to show up. What I want to do is I want to do eventually 10 of these gestures in these 10 seconds. I'm going to use a label, which is up here. So that way every single data set that is generated when I'm doing that capture, that sampling, will be labeled up, right? So let me do that and let me go for it. During 10 seconds, I'm going to try and do that. My gesture will last 1 second each time. Pretty simple. And now in the Edge Impulse Cloud, I can see that I have data coming up. Axle X is the one moving the most. Y is not moving at all. I'm going to do a capture for down gesture. Do the same thing, 10 seconds, the other way around. Okay, there we go. Pretty straightforward for the capture of real data from your sensors to be sent all the way up to Edge Impulse. It didn't take me a very long time. It was really easy. And now I can do that and iterate on that to have as much data as possible. The more data, the better your model will be. From here, I would go about creating the impulse and training my model. Let me switch to a project that's been already prepared before. So let me go to my Muon gesture one. So no devices right now. I'm going to do a little trick here. I'm going to connect this device now because I know I'm going to need it. You see it's not connected, Muon Olivier, not good. I'm going to go back to my data forwarder here. I'm going to stop it. I'm going to restart with -- clean. And remember, it was asking me for which project I wanted to connect it to. So COM3 is still the same. It's going to ask me which one. So not test Edge Impulse, but this guy here, detecting Axle X, Axle Y, Axle Z. And how do you want to call it, right? Oh, actually, it already has a name. It's now connected. Awesome. So here I have my device connected to my project. I could go back to data acquisition and add more data to my project. So in Edge Impulse, I created that project, the model. I worked around the time series data, how to deal with it, a few settings there. I did document in an article all of these settings. They're pretty straightforward, but I would definitely invite you to go and check it out. Edge Impulse documentation is really well made too, so you can definitely understand all of that. I did understand, so you can understand as well. So here I created a set of features that are the pieces of information that the neural networks created upon, and that constitute my model, right? So went through the spectral feature generation. So based on the various samples, I was able to configure, how I wanted my filtering to happen to kind of clean up the data, and how it would be, cutting in chunks the 10-second captures into windows. So if I look, for example, here at the down one, so you see here we have one gesture that is containing about 1 second. So this is the window time that we are setting up in the first stage for the time series, and then some of the filtering that will extract what you need here. So the classifier is then leveraging these various features that have been created. Oh, let me actually go back 1 sec to the features themselves that have been generated. So I did the setup, the filtering, the features were generated. So that actually extracted each of these 1 second windows and was able to say, hey, no, this is tagged as a down, and here is the various parameters or features of the data that has been captured for X, Y, and Z in there, right? They call that the spectral power. That's the type of filter or analytics that I've been applying here. So here you see the features are in chunks, in aggregates, because they are displayed here based on this various spectral power measurements on the various axes. And so they are just showing up in there, and I'm able to navigate through that and determine that it seems like I have a good set of data, because now I can visually identify each of these elements, each of these different features chunks. And so that means that my model certainly is able to do the same. So in the classifier then, you will run a certain number of training cycles, and you will check the accuracy here after you have done your training. So you will decide whether you think, hey, this thing is pretty good or not. So that's all the training and so on. And once again, not an expert and solely, say some stupid things about all of that. But I think I kind of understood what was going on. So I'm sure, once again, you guys can. One interesting thing is that if I had to export the model now as a binary, compile it, put it in my device, it would certainly take some time, right? So how about you do actual testing from the cloud? So here, using the same mechanism that allowed me to capture data for my training, what I'm able to do right now is to start sampling for, let's say, 2 seconds, and try and the gesture on my actual device that I'm going to bring up here and see if it detects it correctly, right? So let me start the sampling, and for 2 seconds, I'm going to do that gesture. Let's see if it's detecting anything. Boom. Here it says idle. Oh, I didn't move while I was doing it. So let's start again. Okay. Waiting to start. Okay, sampling. So it detected idle because I stopped too soon. And here I did up and one uncertain, right? So that's pretty good. That means that there's one that he was like in between up and down. What have you done here? That's okay, because, if that's something we don't know once, we'll just discard that in our code. That's fine. So here up was detected a couple times. If I do that and now go for the down, let's see if it's able to detect the down. Down 3 times, perfect. I love it. Okay, so here I'm able to test my model without having to deploy that on my device. That's pretty powerful, right? Once you've done your testing, you will deploy the model in the right format. And the right format could be anything. If you look at the collection of available deployment options, you can go for like a portable C++ library, target Arduino, CubeMX, whatever, right? So there's a huge list of targets that are platforms, binaries, whatever, so that you can pick from. It's pretty powerful. Particle is one of them. So I just have to type particle here, and I'm good to go. I would just use the default settings, do a build. It's going to put everything into a binary, and this binary happens to be a zip file, and the zip file contains a certain number of things. Let me actually show you the zip file here, content. That's my recognition model. In there you have a README. You can import directly the model. It has samples into your particle environment, but I'm not going to do that. I'm going to import the model into my application, my existing one, because I don't want to just use one of the samples. In the source folder, you have what's interesting for us here, which is the build, MK, the TF Lite model, the actual model with its parameters, and the Edge Impulse SDK. So these are the things that we're going to import in our project. So copy paste in Visual Studio Code. So let me switch to my project. I have these libraries imported here. So this folder, sorry. So here I have this little guys. I did import, and I'm going to use that in my code. If you look at the folder above into the export from Edge Impulse, so the sample folder, I definitely use that one to create my code over here. So let me walk you through that code real quick. So you see it's copy paste from the SDK itself, but I did some modification of my own here. The code is really straightforward. As you'll see, there's a setup function that prepares the accelerometer the same way we did before. And then in the loop, it will get the data, put that into a table, gather a certain amount of that data, which is the window size that we want to send to the classifier, to the model, for it to do its inference. And then we'll look at the result of the inference. And if the inference result says it's up or it's down, we'll do something, right? So I think we will send a gesture up or gesture down to the particle cloud. right? And that's it. So nothing else. We're not sending the accelerometer data up to the cloud for something to happen. That's one of the goodness of TinyML or Edge AI, which is running your inference down on the device itself. So here you see it's like very simple. I gather the data into a table, and then I call this function run inference. And depending on the result, I send a message up. So let's look at the run inference function. This is where the magic happens. The run inference function, I wrote it, but basically, once again, inspiring myself from the sample. I didn't invent anything there. In there, what it does, it looks at the size of the table to make sure that you have the right amount of features for the model to be really efficient here. It does a little trick here to keep this, the features, the table in Flash. No need to overload the RAM for that. And then it will run the classifier. That's this one call that is calling the model to do the inference. And you pass the table, and then you have a result. And this result, there could be some errors. And if it was successful, you go through the different labels of your model. So we have 3 of them, up, down, and idle in our case. And for each of them, you see the score of the inference. And if the score is above 0.9, so 90%, we'll decide that we have detected this gesture with a specific accuracy that will be reported as well, right? And then you just return the value, up or down. That's the idea. We don't want to return idle, okay? So as you see, pretty straightforward. So from here, what I would have to do is like build the code and deploy like a regular, sketch or application for Particle. But there's a little caveat here. There's a little bug while I'm recording that prevents me from successfully building on Windows. Some issue there. That's okay. There's different ways you can build your Particle binary or firmware. One is local. Another one is cloud. You can invoke the Particle clouds through command line or through the tools in the Particle Workbench. But you can also use Docker. So there's this notion of build pack. You can download a specific container and you can execute the build from there. So that's what I did here. I'm running Docker. I got this Particle build pack -particle -firmware, and that's version 590 for firmware version 590 M-SOM, because I'm targeting the M-SOM. And I use the parameter -e platform ID 35. This is once again for the M-SOM, for the Muon device /M404. And here you also have a couple of parameters for the input and output to be mapped so that the Docker container, the compiler in there, can read your code from the local folder and output the binary. Okay, so like pretty straightforward command here that I'm running from the terminal in order to flash, to compile, sorry. So if I look here, I already ran that before and it did output that firmware.bin file here. It takes some time, right? So that's one of the reasons you don't want to recompile your model every single time into your firmware and redeploy it. It takes time. So I tested that model on the Edge Impulse cloud using the real data from the device, and I was able to now export it and I will flash it, right? So to flash it, it's pretty straightforward using the Particle cloud, the Particle tool, sorry. I will call the Particle USB list, identify and find the device in the list here, and then I will do a flash. Let me run the flash here. It's going to grab the binary and flash it on that device. So once again, while it's doing that, I want to show you real quick. When we detect in our loop that we have identified a up or down gesture, we're going to call it particle.publish, which will send a message, an event, sorry, called gesture up or gesture down, depending on what kind of result we found, right? So the device has been flashed. What I want to do is just reboot it real quick to reset the accelerometer. And I'm going to switch to my Particle portal here. So let me clean that up. And we're connected to that Muon device. It's online, or it's rebooting right now. So it will show online in a second. Refresh. Okay, once it's online, we will start seeing events when I move it. I'm not going to move it immediately. And the reason why is because something has been set up that will happen. when I receive an event from this device, I want to trigger a webhook in order to do something, right? So I added a little integration here when, and I did the webhook, custom webhook one I'm using here, and I'm invoking a service that is someone has published as open source. It's pretty cool, and he's hosting that. So you call that service, and it will start a Alexa routine in your home. So you log on this service with your Alexa account, and it will be able to start a routine remotely, right from here using a webhook. So it's pretty powerful. Once again, I document that in the article, so I won't go into detail. So when I receive the gesture down event from my Muon device, right? So I did, so that's the name of the event, and that's when it's coming from this device here, I will invoke that webhook. Right, so that's pretty straightforward. So let's go back to the device itself. Let's see what happens when I start moving things around. We'll bring the device entirely here, right? So you can see the device in my hand. You can see what's going on here. I'm going to do a up gesture. The up gesture has been detected, sent up to the cloud, and look at that. My shades are going up. Now, if I do down, it's detecting down several times, and it's going down, right? Isn't that cool? Up. Off we go. So now I have a gesture activated shade control, right? Pretty cool. So you saw it was like not so hard to go through these steps. Collecting data from real sensors, pretty straightforward. Creating the model, it's complex, but Edge Impulse really simplifies that and optimizes the model for your specific targets. Last but not least, doing that integration or testing before and then integration of this model into your code with Particle, as you've seen, is pretty straightforward. So I hope you like this very fast and short demo. If you liked it, like the video. See you soon. Bye.